Today we're going to be talking about the Doppler effect. Now, first of all, the Doppler effect was discovered in 1842 by an Austrian scientist of the name Christian Doppler and has many real-world applications, such as in astronomy, where it is used to locate the distances between planets and stars and is referred to as redshift and blue shift. Similarly, it's used in radar to calculate the velocity of moving objects. But what is the Doppler effect? The Doppler effect can most easily be described as the compressing of waves as they move from their transmitter towards a receiver, or the opposite if moving away from the receiver. Now let's go over a real-world example of the Doppler effect. If you've ever been in a car and heard an ambulance coming up from behind you and noticed that the sirens sound different when it was 100 yards behind you compared to when it was right next to you, it's because the sound waves were changing over those 100 yards. That is the Doppler effect. Now let's apply what we know to a practice problem. In this scenario, a police officer's car is moving at 25 meters per second and its siren is sounding off at 600 hertz as it makes its way to a bank. On the way there, the officer passes a stationary civilian. What frequency did the civilian hear the siren at? First things first, let's analyze the information that's been given to us. First of all, we're told that the velocity of the car is 25 meters per second. Next, we see that the frequency of the siren itself is 600 hertz at the source. Lastly, we're told that the civilian is stationary, which means he is not moving, so his velocity will be 0 meters per second. Now let's take a look at the formula. The frequency heard by the detector is equal to the original frequency times the velocity of the source plus the speed of sound over the speed of sound plus the velocity of the detector. However, in this specific example, the velocity of the detector is 0, so we'll just leave that out of the formula for now. Now let's plug in the information we know to our variables. The original frequency is 600 hertz. The velocity of the source is 25 meters per second. The speed of sound and air is a constant, but for simplicity's sake, we're going to round it off to 345 meters per second for this example. Now let's put the variables in the formula. So the original frequency is 600 hertz times the speed of the source, 25 meters per second, plus the speed of sound, 345 meters per second, over the speed of sound. Once it's all plugged into the formula, all that's left to do is plug it into a calculator and solve for the final answer. Once you plug it in and do all the calculations, you can see that the final solution is 643.4 hertz. This is the frequency at which the stationary civilian heard the passing siren at. This concludes our brief demonstration over the Doppler effect.